So good morning all the students. In previous lecture, we are discussed about function generator. So in the last class, we are seen how the different waveforms like triangular wave, square wave, sinusoidal waves are generated by using function generator. So mainly in the function generator, you can see in the function generator we are observe how the generation of square wave, triangular wave, and sinusoidal waveform. So the basic thing in the function generator is integrator. So by the integrator circuit, we can obtain the output voltage. So which is the voltage across the capacitor will be considered as generation of triangular waveform. So from that triangular waveform, we can produce the sinusoidal waveform, and also from the voltage compartment we can produce the pulse waveform. So with this square waveform, so with this we can get the three different output waveforms from the function generator. And coming to today's session, so that is pulse generators. So in the last class we are already discussed about the difference between a square wave and pulse generator. So a square wave is derived from a pulse generator when the duty cycle is 50%. Duty cycle is 50%. That is, pulse width is half of the when the pulse width of the square wave is half of the pulse period, then we can say it is a square wave. Square wave. Okay. The same by using the pulse generator, we can also produce square wave as well as pulses with the required duty cycle. So desired duty cycle we can generate the pulses by using this pulse generator. So in this pulse generator also, the this block diagram or this figure shows the block diagram representation of the pulse generator. So main blocks which are presenting in the pulse generator are, so the main upper current source, lower current source, switching circuit. So here we have one of the main component, which is the ramp capacitor. This ramp capacitor. Okay. So and another one is the schema trigger. Schema trigger. So this schema trigger will produces the pulses to connect this ramp capacitor to the upper current source and lower current source. So ఈ పల్స్ జనరేటర్స్ లో మనకి ముఖ్యంగా అప్పర్ కరెంట్ సోర్స్, లోయర్ కరెంట్ సోర్స్, schema trigger, ramp capacitor, ఇవి మెయిన్ కాంపోనెంట్స్ అన్నమాట. So based upon these main components, it generates the pulses. Okay, ఈ four components base చేసుకొని ఈ pulse generator will produce the pulse waveform. Okay, so assume that initially the schema trigger producing the positive output. Initially you can assume that schema trigger produced positive output వచ్చినప్పుడు, so then the output of the schema trigger is connects the switching circuit. So here depending upon the positive, when the schema trigger output is positive, then it connects the upper current source. When the schema trigger output is changed, it means when the schema trigger output is lower, so it connects the lower current source. That it connects the lower current source. That you will see in the next basic generation how it is. So here a constant current source which is producing I1 of the current, and a constant current source produces the current source of I2. Okay, and here we have a ramped capacitor, and this is the schema trigger. So these are the waveforms of the currents when the schema trigger output waveforms. These are okay. These are the currents I1 and I2. The current sources I1 and these are current sources I1 and I2, and this is the output of the schema trigger. This one is the output of the schema trigger. So it is a triangular waveform like shape. Okay. So initially assume that the constant current source I1 is flowing through the capacitor, and due to that the capacitor will be charges. In such situation we have a current of I1. So I1 is and this is the output of the schema trigger, you can say. So it is nothing but it produces the linearly increasing slope. So the voltage across the capacitor is increasing until there is a limitation for the maximum value, and similarly we have a limitation for the minimum value. So schema trigger lo manaki there are some arrangements are there. So up to certain limiting value of the maximum value, so the schema trigger will be after reaching the value across the capacitor to a particular level of the maximum value, then the schema trigger will changes its output. Schema trigger output change అవుతుంది. ఎప్పుడైతే మనకి కెపాసిటర్ దగ్గర ఉన్నటువంటి వోల్టేజ్ అనేది సర్టెన్ మాక్సిమం వాల్యూకి రీచ్ అయినప్పుడు schema trigger changes its output, and that makes the switch to be connected to constant current source I2. సో దానివల్ల ఏమవుతుందంటే కాన్స్టెంట్ కరెంట్ సోర్స్ I2కి కనెక్ట్ అవుతుంది. సో అప్పుడు the capacitor will try to discharges through the current source I2. It means it is having a negative source of current and this is having positive source of current, and like that you can consider when it is negative value, the capacitor will be discharges through this one. The capacitor will be discharges through this one, and in such situation the current I2 is maximum. So like this we have some constant current source will have the control over the discharging capacitor, capacitor discharging. So when the capacitor is discharged to a certain minimum level, when the capacitor discharged to a certain minimum level, the schema trigger again changes its output, and due to that it connects again to the current source I1. It again connects to current source I1, and again the current will try to rise. The current source will starts to rise, and due to that will produces a constant current I1, and at that moment the constant current source is lower value, it produces the lower value. Again, when the voltage across the capacitor will be increased to a certain value, so at that moment the I2 is 0. So when it is reaches to a certain maximum limit, so then the schema trigger will disconnects the constant current source I1 and connects the I2, and due to that the current through the I2 will be increases, I1 will be decreases. Like this we will get two output waveforms, I1 and I2. Okay, I1 and I2. So these output waveforms will be represents these output waveforms by making like this. We can get the output waveforms. This represents the pulses. So depending upon the duty cycle. So duty cycle is the ratio between I1 by I2. Is the ratio between I1 by I2. So depending upon that, we can produce the pulse waveform. So this is the pulse generator block diagram. So from this schematic trigger, we can directly get the trigger output circuit. Okay, trigger output circuit we can get, and similarly we can also produce the at 50 ohms output. So we can also get the 50 ohms output amplifier and step attenuator. So we can also get the 50 ohms range of output. So with a peak of 5 volts peak, and it is producing a falling step of 5 nanoseconds. And similarly for the 600 ohms output, so we can get 30 volts peak output voltage. So with this we can get the different voltage ranges also. So for 600 ohms output point, at this point we can get the 30 volts peak value, and for this there is a using of the attenuator. By the using of the attenuator, the voltages, generated voltage will be reduced. We can, according to our desired output, we can choose the attenuator circuit, and from that we get the peak value of 5 volts. Okay, like this. So here it is. There are some frequency controls. So from the we have in the selection range of frequency, we have an option in the front panel of the pulse generator. There is a provision to change the control. So generating frequency control option will be there. So with that there is a generation of the change of the frequency. Okay. So like this we can understand the generation of the pulse waveform. Okay, if the generated pulse waveform has the time, the pulse width of the generated waveform is half of the period of the pulse, then it is nothing but a square wave. So with this we can generate the square waveform as well as the pulse waveform. Both waveforms can be generated. And the next one is random noise generator. Random noise generator. So here it is also one of the important signal generator. So noise, all of you know that noise is nothing but the unwanted signal we can consider as a noise signal. So which generally will interferes with the actual signal, actual signal, and so with this random noise generator, we can produce the output waveform, output in the audio frequency range. In the audio frequency range, we can generate the noise output. So noise signals also used to analyze the noise of the for a given signals. So for that purpose, it is also very important generator for analysis of the signal to noise ratio. Analysis of the signal to noise ratio, and this generator will produce the 3 types of noise signals. So white noise, pink noise, and Usasi noise. White, pink, and Usasi. So these 3 types of noise signals will be produced by noise generator. So this generation of noise signals will be in the random fashion. So there is no sequence. So it will produce in the form of random fashion. So for that, what are the main components will be may present in the random noise generator means. So this figure shows the basic components or basic blocks of the random noise generator. So the first one is noise source. The noise source is having a frequency range of 80 to 220 kilohertz. So the noise source will generate the noise signals in the range of 80 to 220 kilohertz, and it should be to amplify the signals, and it is given to a modulator. So where the modulator, the this 80 to 220 kilohertz signal frequencies was heterodyned to 0 to 100 kilohertz. So what is the meaning of heterodyne? So heterodyne is nothing but the decreasing the, here in this case it is nothing but the decreasing the frequency range. Decreasing the frequency range. So the generated noise signal is in the range of 80 to 220 kilohertz. So that signal will be reduced to the audio frequency range of 0 to 100 kilohertz range. So with this we can obtain the frequency range around 0 to 100 kilohertz, and after that the signal will be applied to white, pink and VSAC filters. So with these filters we can produce the this filter will be separates all these three noise signals, and those signals will be amplified and we will get the noise output. Okay, so for that, so how the we are seeing that in the previous slide that noise source is producing 80 to 220 kilohertz of frequency. With that frequency it is producing a noise signal. So what is the basic noise signal is present? So what is the noise sources we'll consider? So this is one of the noise source. So using the which is connected in reverse bias. So this is the input side and this is the output side. So it will produces the noise signal, and this is the source of random fluctuations in the voltage. So it is a pink noise source. You can see it is a representation of the pink noise source. So a noise source will generate the noise signals, and after that the signal's strength will be increased by amplifier and gain will be improved by an amplifier, and the generated frequency range will be modulated to, this is decreasing by using heterodyne process. So we can decrease the frequency range from 0 to 100 kilohertz. So like that we can after that we will get the by using filters we can get the individual noise sources. We can separate. So from that, so these are some of the representation of the noise voltages with the frequency, it's in the frequency ranges. So if you observe this is a white noise. It is the white noise. It is the white noise is having some flat representation. So the voltage in millivolts range, okay, and frequency range is 100 to around it is 200, 110, 150 like that it is there. Okay. One kilohertz in the kilohertz range. So generally white noise, this is white noise, its structure is like a flat, it is flat from 20 hertz to because it is white noise is in the range of white, it is like a white color source. And so for the coming to pink noise, for this pink noise, the input at the initial stage, lower frequency range, the pink noise signal voltage is higher, it has higher value. The voltage of the pink noise having higher value at lower frequency range, and the voltage is going to decreases for increased value of the frequency ranges. So similarly, USASI noise. So USASI noise, it represents the energy distribution of speech and music frequencies. It is used for testing audio amplifiers and loudspeakers. It is relates to speech and music frequencies. It relates to speech and music frequencies, and it is used to test the audio amplifiers and loudspeakers. This noise, with this noise we can test the audio amplifiers and loudspeakers. So up to now, if you have any clarifications, you can ask. So what is this in between we are getting, students? Who is doing this? Don't do such activities. Because it is recording. So the next one is so sweep generator. So what is the sweep voltage? So how it is different from the triangular wave signal? So how can we differentiate the sweep signal? So sweep signal is a sinusoidal output signal. It produces a sinusoidal output signal. So you'll see the sweep generator in the next class. With this, I will close in the session. Okay. Thank you.